Hello, my name is Luca, and today I'll present a technical project video for GIT 335. My topic is additive manufacturing, and I'll talk about how this technology can completely change how the world is engineered for the next decade. Additive manufacturing is defined as a process by which 3D objects are constructed by successively depositing material in layers such that it becomes a pre-designed shape. In other words, 3D printing. Subtractive manufacturing is defined as a process by which 3D objects are constructed by successfully cutting material away from a solid block of material. In other words, machining. In 1981, Hideo Kodama made the first use of a 3D printer, but he failed to patent the device. In 1984, Chuck Hull invented stereolithography, which is a type of photopolymerization. In 1986, Chuck Hull patented the first 3D printer and the first 3D model file type, the .stl. In 1990, the first industrial printer was created, and in 2001, the first desktop printer was created after multiple 3D printing patents started to expire. Only after patents began to expire that 3D printing could finally be more accessible. 3D printers are now being widely used by the general DIY public, and they changed the prototyping world forever. The industry still has not adopted 3D printing in scale, but its technology has so much potential. Why the industry is lagging so much behind the general public? After 3D printers were invented in 1984, multiple other types were created, each with different capabilities and applications. Vat polymerization was the first one created, and it consists of a vat full of photosensitive resin. A source of light is then used to selectively cure layers of the part one after the other. Powder bed fusion is a process like the vat polymerization. It consists of a bed full of powder that is selectively molten by a focused laser beam. After each layer, more powder is deposited on top. The process enters layer upon layer until the part is complete. Common materials are powdered metals and polymers. Binder jetting also has a powder bed, like in powder bed fusion, but instead of having a directed laser beam, it uses a jet of liquid photoresin and a light source to solidify the powder together. After each layer is complete, more powder is added to the top and more resin is jetted to the powder. After a part is done, it can be cooked to burn the resin off and melt the powder together. Material jetting also jets a photosensitive liquid material layer upon layer on top of each layer. The traditional 2D inkjet printers use a very similar process, but it jets ink instead of other materials. Material jetting is different from other resin printers because it heats up the resin to achieve the printing consistency. Material extrusion, also called field deposition modeling, is one of the most common types of 3D printing. Most desktop printers belong to this type. It consists of a polymer filament that is extruded through a hot end. There are a lot of materials that work perfectly in, like ABS, PLA, polycarbonate, nylon, PETG, even chocolate and clay. But materials like metals cannot be printed this way because of the extremely high temperature gradient within the part. Now let's talk about the pros and cons of additive manufacturing. Starting with the pros. Freedom of design, because 3D printers can manufacture complex shapes that would never be possible otherwise. Rapid prototyping, because of the flexibility to print different parts just using different 3D files. 3D printers can make stronger parts using finite element analysis and variable densities according to the stress. It's also capable of print hollow parts or cellular structures. Waste reduction, since additive manufacturing does not need to subtract material from a block, for example. Flexibility, because you can print different parts without the need of changing the setup. And cost effectiveness, because parts with very low demand can now be manufactured at a much lower cost than with heavy machinery. The cons of 3D printing are limited materials, especially metal printers. They have very few different alloys. It's possible to 3D print a final product, but in many applications, post-processing is desired to either change the properties or the surface finish of the material. Printers also uh, are also not cost-effective when large volumes are required. It could never compete with a stamping machine, for example. Because 3D printers work layer upon layer, delamination can occur. Low temperatures can increase the chance of delamination. Another flaw of layer upon layer process is that 3D printed parts properties are directional, so they're not the same depending on the direction you're testing. As I mentioned before, only few metal alloys are available, but many metal printers exist. So why does the industry has not widely adopted it yet? That is due to the lack of specifications for the material and process. The lack of specifications limits the engineers in terms of safety. SAE International has recently released the first ever set of specifications. Specifications include a handful of alloys, and they are about the powder manufacturing, the powder bed fusion 3D printing process, and the tests and results for the 3D printed material properties. Even though additive manufacturing is not an heavy industry nowadays, it is making significant advances in some sectors. One of them is the aerospace sector. As you guys can see in this picture, rocket nozzles have really complex geometries, and with 3D printing, they were able to take it to the next level in terms of optimization and weight reduction. Additive manufacturing is proving to be useful in reverse engineering parts because it's able to manufacture parts that are not manufactured anymore and that would be expensive to create another manufacturing line. Medical is another sector 3D printing excels because it can reproduce with great precision the organic geometries of the human body. Using stem cells from the patient itself, doctors are printing organs that could in theory supply all the demand in the world. Because stem cells are from the patient, there is virtually no risk of rejection. The only problem with 3D printing organs is that no functional organs were ever printed. We will have to wait until 3D printed organs can be transplanted into people.